of you. Sometimes, truly, sometimes I write code and I begin to hesitate about something, and I just like grab this program and start clicking around and see if I already have something similar to what I'm trying to do, and just watch what happens. Because like I said, this is a true recording of what is happening at runtime in memory, and it's capable of visualizing it. So it's sort of like a helpful little tutorial that essentially gives you an insight of these containers. Because if we just go through these presentations here, then it's a little harder to work with the examples and observe the new syntax and also think about what's happening in the background. So let's see if we can get through a few more of these demos. So we jump to vector constructors, stack operations, list operations, container types. I don't know what this does here. I will move on to the next example. This is not very significant example. Iterator and begin. So it's also very specialized. There's nothing interesting about this. Size. Okay, so this is good. Straightforward element access. We used already square brackets with the vector and index, and it worked. So of course this is element access. So here it is, vector of 5 zeros, right? Create vector of integer and populate it with 5 zeros. This is the type of constructor that exists. Takes 2 integers. In my case, it's populating with 5 integers. And then we say, then we can say, like have a loop, right? Where I say starting from 0 and less than the vector size plus this little integer I. So populate each element with 10 plus I. So I get 10 plus 0, 10 plus 1, 10 plus 2, and so forth, right? So we had a loop where we updated the content of our vector. Now, you can also refer directly to the first element and the last element inside the vector, right? So front, it's basically, look, I can just say vector front. Well, guess what front returns? It returns a reference to this integer in memory. And when I say this integer equal 1, of course, the new integer gets stored there. So front returns a reference, and back also returns a reference. So here it is, back equals 1, right? So vector back function call returns back a reference which is pointing to this integer, and therefore it can be used for storing brand new element there. Now the square bracket style of accessing elements inside the vector, it's called unchecked access. Basically, if you mess up this index, you will essentially memory access violation. The program will crash because of that. So it's like programmer knows better. However, there is also the add function, which is doing the checked access to the vector. And what it says here, one important aspect of vector compared with other containers is that one can easily and efficiently access individual elements in any order. However, right, if you do add, it will throw a specific type of exception which you can catch, and this way you can verify that looking at the 4th element, at the 0th element and the 4th element is safe. So in addition to array style access to individual elements, there's also an add call which will throw a specific type of exception which you can catch and basically manage, make sure that every time you specify an index, direct access to elements inside of your vector, that the range is checked, and if something is wrong, it will. This thing doesn't demonstrate it, but just to be complete, we can mention that thing does exist there as well. So that's pretty much all demonstration that I have in terms of animation. Those are some special cases. I really don't even want to go there. Let me see. Function objects, not the topic for today. Iterator adapters. We can talk about it also at some point later on. So a few examples of algorithms. Those are very simple. Examples of algorithms. So far we were looking at the find example, right? So find something like this, push back something, push back like pairs of integers, and then find particular value, and it finds it, and then you can display it. Let's make sure that we talk about this, I guess. The simplest, you may think that a vector may be the simplest and the most straightforward container in standard library that can possibly be. Well, the answer is yes, because it's a dynamic storage. But there's another very primitive container that exists. So let's talk about this. It's called pair. I don't even know what header file pair is defined in, but I'm sure that it's probably already in. Well, actually, let's find out. So if I say okay, and if I search for a pair, so it tells me pair. So actually, it's included in the utility. In the utility header file. Okay, good enough. So I'll say it here. Include utility. Okay. Oftentimes, you need you need to organize something as a pair of values. So what you can do is this. And for instance, I would like to have a pair of string and integer. Okay. So pair is extremely simple, extremely simple type of container that basically will take one string and one integer. Here's a pair of two strings and I just named them stir pair and things like that. And here's a pair of simply two integers. Right? So these things are helpful to basically create a very simple association between the two particular types of variables. Pairs are used extensively in building trees. Maps, basically key value pairs, all kind of situations. We're going to see when we explore the functionality of maps. We're going to come back to this pair, but it kind of surfaced here right now. So it's very simple. So now I have this guy should be called int pair. Int pair. So to populate those guys with values, the pair is so simple that it doesn't have any functions built into it. There's basically just the first placeholder, right? So hello again, something like that, and my pair second equals 1, 2, 3, right? So it's a very simple type of container. Very simple type of container. Now, And similarly, you know, two strings or two integers, it's your choice what kind of types you want to parameterize your pair to work with it. And then, of course, it's possible to create vectors of those things, right? So, this is what this particular sample demonstrates, that we create a vector of pair of two integers, a vector of a pair of two integers. Now, let me save this.